Thanks, folks. Hey, everybody. Those of you that are on the call, I'm excited to share some ICS and OT specific stuff with you. Let me minimize this screen. My name is Vivek Ponnada, and here's a quick background of who I am. I've been in industrial control systems all my life. In fact, right after high school, I became a technician, instrument technician, and I graduated with electrical degree later on, but I've been doing ICS all my work life. I've been doing OT cybersecurity for the past 8+ years. Most of the past 10 years has been sales and business development. I do dabble a bit on the services and execution, and like many of you in the industry that have been around for a while, I've traveled and worked in many countries. I do have a finance MBA as well and a SANS cert for industrial controls. Here's my contact info, and let's dig into the agenda today. So we'll talk a little bit about the industrial control systems, the PLCs. We'll talk more about the top 20 PLC coding practices project, and we'll go through some examples. So first up, PLCs, folks. Nobody is surprised to see Purdue model here. Most of the discussion that you see around industrial controls typically starts off with saying, how do you protect the internet-facing devices, right? So anything in the DMZ at this phase, level 3 above, or maybe even the HMIs and historians and EWS at this level 2 or 3, even down to level 2 HMIs. But you don't hear about securely doing anything at this level 1 or below, because historically there was no protection, no focus on security at this level 1 or below. So in fact, you hear about this term insecure by design, because these PLCs, both the hardware and the protocols, the communication protocols, were never built with security in mind. So if an attacker or malicious actor is in this area already, having done whatever, lateral movement or direct access through some kind of IoT device, either way, once they're here, they can operate no differently from a maintenance person or an operator, because the protocols, they'll just execute whatever commands are given, right? So they don't really look into who's doing the initiation of a command. So historically, again, no encryption, authentication, etc. Now we talk about PLCs, but what I'm going to talk about today is equally applicable for distributed control systems or the SCADA systems as well. We're just talking about the level 1 controllers. Okay. All right. So next up is the background on this top 20 project. So a couple of years ago at S4, which is a OT specific thought leadership kind of cybersecurity conference, happens every year in January in Miami. Jake Brodsky did a presentation talking about how there are things we could do at level 1. There are things that we could do to improve the security of PLCs, have a better posture, security posture, and also be able to help in case there is an issue and help in forensics and incident response. He did this presentation, and then post that, a lot of people felt like they should be developed further, beyond the presentation, to get like a list that the community can actually use. So they then registered on, an ISA website and solicited people to contribute. About 1,000 people, register, and several dozens actually contributed for the next year. And after a year, we now have this PDF file ready that has the top 20 practices. I'll post this link again in the Discord channel, but you can download this. There is no need to register. Just download it and use it as you see fit. But these practices are written for engineers. These are not written for OT practitioners. Of course, OT practitioners could use this and pass it on to the engineers, but the key reason why we did that was we wanted to improve the coding of the PLCs themselves, right? So these engineers that are coding these control systems are whom this is targeted towards. The goals are, obviously to make the PLC code a little bit more robust, or at least less vulnerable. Also, use some of these mechanisms, built-in redundancy, software coding buildup, some kind of fallback mechanisms, and also improve the secure by design mechanism. And then assistant documentation and logging, etc. When you get to an incident response kind of situation. So we mapped all these practices as much as possible to the MITRE ATT&CK framework for ICS, CWE, ISA standards 62443, as you would expect, right? So that way, we are following industry standards and frameworks. But this list is essentially a practices list. It's not a standard by itself. Also, it adds a layer of protection in places that none existed before. So thereby, the PLC code itself will be less error prone and makes it harder for an attacker to accomplish what they were trying to. That's the goal, one of the goals behind this project. Let's get into this list. So we have these 20 items here. We're going to take a few examples and elaborate them a little bit more, but I just wanted to pause just for a second here so you can see the list of top 20 practices. Again, like I mentioned, I'll provide the link. You can download this with more detail there. It's like a 40-page document that has all these different practices and explains in detail with some examples. All right, let's go into this list with a simple one first. So one of the practices, practice number 2, talks about tracking operating modes. So those of you that are very familiar with industrial control systems, I'm showing a PLC here, with some I/O and some power supply. As you can see, you have a switch here that typically has multiple modes. One of them happens to be run, the other one would be typically program and maybe remote. So the idea being, when in run mode, the code is being executed by the PLC. When it's in program mode, you're able to download code to the controller. And when it's in remote, you can then choose whether to program or run, from a distance via software. So the guidance here from this practice is to say that, keep the PLC in run mode. And if it's not in run mode, it should be an alarm to the operator. And, again, at the end of the shift, make sure the alarm pops back up, because if someone were working on this PLC, the operator would know, right? And they would acknowledge it. And then end of the shift, maybe they close the permit out and then, enable the PLC to go back to run mode. Now, there are reasons why it's typically left in remote, because, this might be in a hazardous area. The engineer might need to put on their coveralls and hard hat and safety boots and to get to this area to or drive even further out somewhere remote to access the switch, or maybe call a buddy operator and ask them to, put this in, program mode when they need to. But the key is, the malicious attacker doesn't have the buddy operator, doesn't have the access to the PLC, right? So we're trying to avoid the risk of this being in remote and someone over the network being able to move the PLC into program mode and download stuff or cause any disturbance to the operation. So the recommendation is to keep this in run mode and always alert via an alarm on the HMI if it's not in run mode. Now you might ask the question, there are some PLCs out there that do not have a switch, so what about that? Again, the goal of this practice is to kind of give you an example of what we're thinking, what collectively OT practitioners or cybersecurity focused folks are thinking. You might have to find alternate mechanisms, right? There might be a password that you can put to avoid a download, or some other way to track, whether the PLC is in a mode that is not running, that is, able to download to the controller. That's what we're trying to avoid, or alert at the very least. Okay. Next up is practice 5, another pretty straightforward one. You might see a trend here that some of these things might seem like common sense for IT folks, but then we're in the OT world where our common sense is different. What we developed code for, programming for, is for process functionality and efficiency and reliability, not so much for security. So again, this practice talks about using a cryptographic hash or a checksum to verify the integrity of the PLC code. Now, some PLCs do have a checksum feature where they automatically generate a checksum and you can save it. Maybe you can even put it on a register and alarm it if it changes. But if you don't have that feature, you can still perform the checksum pretty easily on the engineering workstation, right? or you can probably do a hash in the EWS of the binary that you just downloaded, so you know that it's the one true code that you are in control of and no one messed with it. So most PLCs can't generate or check hashes on their own, so you have to do that from the engineering workstation. So again, the key is to ensure that you're able to verify the integrity of the code, okay? Next up is practice 7. Again, I'm just going through some of the examples so that you get a feel for what these PLC practices are doing, right? This happens to be one of my favorite ones, where it says validate and alert for paired inputs and outputs. So the way we define these paired inputs are, these are things that physically cannot happen at the same time. So as an example, a valve cannot be open or closed at the same time, right? Or a motor wouldn't have a start or a stop command and a stop command at the same time. So that way, if a malicious attacker is trying to just mess with outputs or mess with inputs, you should have a mechanism to say, this is physically not possible, right? So these two signals shouldn't be coming in at the same time. Now, they might be coming because of a limit switch fault or some kind of MCC failure, but having this alert kind of tells you that there's something going on out in the field that you need to inspect or troubleshoot, right? That's the idea. Now, if possible, I'm using a ladder logic example here. Typically you have this motor start command. If it goes away, then it's stopped, right? But what we're saying here is configure start and stop separately if at all possible. That way it's two different outputs going to the MCC. And if the MCC is able to take those two separate inputs for motor start and stop, that's ideal. And then disallow the rapid change of output states, meaning if some malicious attacker is able to just force this motor start or stop on and off, right? You should have some kind of software timeout or something that disables the output, from being toggled pretty quickly. Now, you might ask the question, wouldn't the attacker then go back in logic and check where that's being stopped and override it? Yes, it's possible, but again, the key is we're trying to improve the code, right? We're trying to increase the robustness of the code, not necessarily mitigate every single possible attack scenario, but make it harder for the attacker, make them read the code even further than they already did so far, or not able to just randomly toggle outputs or bits from a Modbus access they have on the network, for example. All right, let's go into another slightly more detailed one. So this is validate inputs based on the physical plausibility. This is actually cool because PLC gets a lot of inputs, right? It gets not only the process inputs, it gets all the pressures, temperatures, limit switch feedback, many things, right? So if you monitor the expected physical duration, as an example, there's a valve, it takes a certain amount of time to go from fully closed to fully open, or a tank with a certain fluid takes certain time to either completely drain or completely fill up. You got to have a good feel for what these numbers are in a usual process scenario, and then alert when they're different, right? So if someone was attacking the bits maliciously or manipulating the transmitter signal, the 420 milliamp signal, or coming from level 3 below, just modify some packets or replay attack of using some past inputs to force inputs currently. If you track this physical duration of what it should be currently in this process, and if it's different, if you get an alert, that's a good way to kind of find out if something is wrong with the process or if someone is manipulating it, right? Similarly, monitor expected physical repeating activity. So some of these wastewater treatment plants have a diurnal cycle where, something's happened in the morning, something's happened at night. Now, if whatever should happen in the morning is happening at night, that's atypical, right? Again, alert based on that, alarm based on that, so the operator has an idea. And the last one, if you all remember, the most recent Oldsmar, Florida hop where someone not only used a remote access to log in, which is a traditional IT vulnerability that we all know, remote access credentials, stolen credentials, but they were also able to enter a value for lie, which was tens of thousands of times more than what the actual lie percentage should be, right? Now, if you limit the operator entry for set points to what is practical and physically possible, that wouldn't happen, right? Now, there are many mitigations. So some of the practices, some of the other practices also have other mitigations for the remote access, for example, or some of the validation and checks in the PLC code. But in this particular case, the key is to allow, for example, let's say the whole process can only take 5% lie safely in an hour. You should only let the operator enter up to that 5%, right? You shouldn't, just because there is a number on the HMI that they can enter, shouldn't be the reason why they have a chance to enter 10% or 20%. So that avoids mistakes being made. At the same time, this allows the malicious attacker, accessing the same input from anywhere else and entering a number that's not physically possible. Okay, that's another cool way to kind of mitigate some of the external threats. This is another interesting example where you trap false negatives and false positives for critical alerts. You wouldn't do this for all alerts, but let me walk you through a scenario. So let's say this is obviously we have many kinds of programming languages, right? So we have function block, we have ladder logic. This could be a function block example where you have a bunch of conditions and they all have to be true to get this trigger bit as 1, okay? And this trigger bit 1 can then go on and do other things, maybe start, stop some pumps, do some other activity in the PLC. But what if a malicious attacker was forcing this trigger bit to 0 on purpose, right? So that the rest of the actions or the sequence doesn't happen. So in this example, we're trying to create an alert for this kind of false negative, right? So this is supposed to be 1, but someone maliciously forced it to 0. So if you build an additional piece of logic where you actually take the output of the same AND gate here, and then take a not of this trigger bit, that was forced in our example, and then AND it to get this alarm. In a forced condition, this would be 0. That means this would be 1, and this is already 1. So you then get this alert that, hey, there is a false negative happening on this particular trigger bit. Okay, you can do something similar for a false positive as well. Again, the key is, we're trying to add another layer of protection where you could make an argument that an attacker would not only force this, but also force this. That's possible, definitely, but this code normally doesn't exist, right? So many of these things that we're recommending in these practices list, based on a lot of experience over many years by many PLC engineers and practitioners, is that the more robust you build a code and the more kind of checks you built in, the more difficult it is for a malicious attacker to just randomly get lucky and be able to manipulate something. So this false negative will alert you that someone is forcing this bit on purpose. Next up, we have several practices that I kind of combined to say these are kind of similar where you monitor, whereas the previous practices we talked about were all about verifying integrity. Some of these practices are more for monitoring. So for example, let's take this first one, PLC cycle time. I'm using this example here where, the PLC cycle time is fairly predictable, right? Because it's a deterministic computer. The process is fairly stable. The IOs and everything that's being scanned, there'll be minor variation, but let's say there's a spike in this. It's possible that someone injected some malicious code that acts once in a while and causes more CPU cycle time. If you trend it on the HMI, then over time what's normal and what's not, right? So most PLCs have the cycle time allowed to be a trendable point, defined point, but most HMIs don't have this information. So the recommendation here is to do that so that you can track it, so the operator has a better view for what's normal and what's abnormal. Same thing with PLC hard stops. If a PLC ever does a reset or a reboot, you should be able to log that and record it. And also PLC uptime. It's kind of like the alternate for the hard stop, right? So when was the last time the PLC started and how long has it been running? Again, that should be something that should be logged. And same thing with the memory usage. So the PLC memory usage is fairly constant, fairly stable. And if it's changing for whatever reason, it's likely that someone is messing with the code, or it might be something wrong with the device itself or something else wrong in the system. These monitoring ideas or these practices are crucial during incident response, because oftentimes you walk into a plant after an incident and you have no idea what's actually normal, what's good for the process, what's expected, what's not expected. But if you're able to log and trend them on the HMI and then even store them on the workstation or on the historian, you then have a way to kind of verify, some of the previous practices we talked about, verifying the code and validating the integrity of the binary that you downloaded the code to the controller. And if you assist this with this kind of data to say this is normal, and whatever is happening now is not normal. So if you have the comparison, then you can really do a better incident response, because you have a good feel for what's normal, what's not abnormal, what's abnormal. This project is ongoing, it's evolving. The version 1 that's published on the plc-security.com website, we're always looking for more contributors, we're looking for more people to get involved in the project. If you are an OT practitioner, I would request that you pass on this information to your ICS engineers, people that you're working with across the plant floor or in headquarters. And you yourself can contribute to the project along with those ICS engineers, either with the PLC knowledge or any of the standards work, the ISA, ISE 62443 or the CWE. We're seeing a lot more people interested in natively improving the functionality on the level 1 devices. The more recent devices have some kind of built-in encryption, they have more authentication options, but these practices are meant for even older PLCs. So if you invest a little bit of time, you'll be able to improve the security posture and help incident response on even older PLCs with these practices. But the key is to educate these clients, our customers, your customers, on the existence of these coding practices. These did not exist before, right? So if someone asked you, hey, how could I better defend level 1? You didn't have a good answer. But now these practices exist, and you can pass them on this document. Similarly, if you're buying something new in the OT world, don't restrict yourself to level 2 or above requirements, right? Those, coming from IT, a lot of IT-like requirements are being passed on to OT, whether it's about patching or virtual computers. A lot of relatively recent developments in the OT world have been restricted to level 2 and above, learning from IT. But pass on these requirements. Don't just give them this document to say, follow these because this is not a standard, but the concepts behind these practices. Please pass on this document to them, giving them the background that it's the intent behind these practices. Here's what we're trying to defend, and here are some of the examples of how you do it in an Allen Bradley PLC or a Triconix or a GE PLC. So put them in the vendor RFQs and ask for more security at level 1. And look forward to answering any questions that you might have. That's the end of my presentation.
Awesome. Whenever I hear about PLCs, it always just brings me back to like Darknet Diaries talks of like Uber APT hacks and stuff like that. It's the first thing that comes to mind. I can't remember the episode, but I literally just listened to it. How'd you get into this type of security originally?
So my background is industrial control systems. Back when I started, I was a controls instrumentation technician. So there was no security focus like 20 years ago, right? Because we just did everything based on functionality, reliability, how to get the process to improve. But then, don't chuckle, but Stuxnet changed the world. If someone was doing a bingo, then they were like, yeah, they're waiting for it. But the reality is, average Joe like me, did not think about PLC or industrial security before then. But since then, the interesting thing is the APT-like behavior, so far from what we know, has only happened 5 times in the industrial security world. So the past decade, there is a group of people, significant experience, a lot of knowledge, that say we should not focus on these APTs because so far they've only been 5 attacks versus thousands of attacks of ransomware type or IT like that happen every second, right? And Colonial Pipeline is a good example. Old Smart Florida is another example. You see these remote access credentials being dumped on whatever, some kind of watering hole attack, and got some information, or two-factor authentication not being used, something goofy, something simple that an average IT person would be like, why in the world, like this is 2021, like why are we not doing these basic things is the question, right? But those things happen routinely. But the APT like long range attack needing access to level 1 or some kind of jumping the air gap environment and beyond the DMZ, those things can happen. But for the average company, whether it's I say average, even bigger companies like Colonial or JBS or whoever, most of the attack scenarios are not at level 1. So they are mostly coming from the internet facing, whether it's some kind of cloud bucket that's misconfigured or some kind of IT like issue that like it's happening every second, and that'll continue to happen in that world. So OT is not immune to OT specific attacks. We're not saying that at all, but the attack surface is much bigger coming in from the IT.
Working from a threat intelligence field, I wonder how many attacks have actually occurred that have just been swept under the rug too, right? Like I feel 5 is so low. There has to be a decent amount out there that everyone's like, you know what? No one talk about this. We don't want
never happened, right?
Yeah, nothing happened. There's no logs. There's no way to prove it.
Well, it's interesting you say that because these are all cyber physical systems, right? So of these 5, when you think about crash override or Havix or even Stuxnet, there is usually a physical device or physical process that got disrupted at the end, and that's how you tend to know. So yes, it's possible that every day industrial plants go through outages, and if it's because of some kind of liability issue, or if it's because of some instrument failure or mechanical issue, or malicious attacker doing something on their own, we wouldn't know unless they tell us. But usually there is a cyber physical element at the very end that's disrupted. So you would think you would know. Like it's hard to escape from that fact. Like you would ask the question, hey, there's a flare. I used to work in Houston, and there's a flare on the east side of the ship channel. Like, what happened? Well, they have to give you an answer. That, hey, we screwed up. Somebody did some mistake, and so we had to flare. Or this device failed, and so we had to flare, or whatever, right? So now, of course, I haven't heard saying, oh, we were attacked, and so that's why we were flaring. But that's possible. That might be this decade, right? So it didn't happen last decade. It doesn't mean the future will follow what we saw in the last year.
I use that as a deterrent. Just because it hasn't happened, it probably won't happen. It's like, just because it hasn't happened doesn't mean it's not going to happen.
Right.
Well, no one's come after us yet, but the day is coming. The target pool is lessening every day. Oh my goodness.
Right. But that's the interesting piece. If you look at a lot of vendors selling security products, it's hard for them, right? Because if you walk into a C-suite and say, hey, here's my product that'll save you from X, but the X hasn't happened yet. How do you get funding for that X, right? So that's why, I work for a vendor as well, and what we focus on is, the current attack surface, right? You mentioned threat intel, follow the money, right? So what is threat intel telling us? Where are the exploits right now? Or if they happen to come from, remote access or some kind of VPN or, some kind of credential theft, focus on that today. Oh, by the way, while you're at it, if you're improving your security posture, buy a tool or a suite of tools that you can expand into OT that can protect you on these other possible scenarios. That way, you're not starting from scratch. If you wake up one day and you notice maybe in your industry or in a sister industry, that something similar, because these PLCs could be used in so many industries, right? From healthcare to transportation to power to oil and gas. So just because something did not happen in power or oil and gas doesn't mean we cannot learn from something that already happened in healthcare or in transportation. So
The
absolutely.
other common thing I see is that people don't really know their own mitigation arsenal well enough. They don't know the capabilities of everything that they have. So like, oh, we need a solution for this. And it's like, well, did you know that the thing you have literally has that capability if you would just turn it on or pay for the extra service or whatever? So people are out there not even fully utilizing the benefits of the things they already have. And so you might not need to go out and get something, or you might have the ability to plug a hole where you just haven't realized it yet, or people don't properly deploy things in the first place. They don't get those sessions with those like support engineers. They don't sign up for the proper onboarding. They just want to take it out of the box and plug it in and spin it up, and do I see assets in there? This is so fun, super cool, we'll work on tuning that later. And then they never do it.
Those manuals are long and boring, all right? No one wants to read those. Like,
Guess who's reading them?
me. Like,
Red teamers.
wait,
Red teamers are reading
waiting
them.
for security manuals. That's what I got to do before I wade through the logs.
Yeah, y'all are awesome in that, red
Reading
teamers
through books.
always trying to help the blue teamers, right? About, what the holes are. I think the biggest gap we have is time and resources, right? There's only so many things. Like the average controls engineer in a typical refinery that I know of is dealing with 100 different control systems in a given day. 100. I'm not even joking, right? And they're not looking to improve on security. They're just trying to maintain the plant and have the plant reliably operate. So they're not thinking about security every given second. So we need to fundamentally improve the security when we offer these products to them, right? It's so hard, like any user, right? Like if you give an average user, taking an IT example, if you give them a Windows 10 box and expect them to maintain it, that's one thing. But if you give them a Windows XP box and expect them to, keep it secure, now that's not practical, right? Like you're not helping them win. So in a lot of these situations, industrial controls have had that legacy where, you run these things for 25, 30 years and they were never built with security in mind. So, they got a piece of cheese. So you're trying to, tell them to protect the cheese. Like, how is that possible, right?
My dad is a SCADA engineer for a local utility, and he was like, I got in there and he's put so much security in, because he's actually a very security centric person. And he tells me about the things that he does, and I'm just like, oh, thank you. Thank you so much. Because
He's a superstar like very few that we have,
Yeah. Because for you guys, it's not a question of if, it's a question of when. You guys are probably getting a dozen hits a day from people trying to take you down. Just ping them a little bit and see how it's going. So it really is very, very crucial for ICSs specifically.
The next challenge for him, if you ask him, he'll tell you the same thing. The next challenge for him is where and how can he transition? Like, let's say he gets a promotion and suddenly, there's no one to fill his shoes. So that plant needs a backup plan, and they typically don't have it, right? So he can't leave the plant in someone's safe hands because there's no one to take the mantle over from him. That's a challenge we have.
Exactly. That is the problem, is like people like him are very hard to find. He'll probably have to do some succession planning. That's another thing that IT professionals don't do a ton, is succession planning. Like, when I vacated my last pen testing position, I was the only person doing all the offensive and security testing at all. And when I left, it fell onto the InfoSec program manager, who, while she had the capability, didn't have the bandwidth. And it took them 6 months to backfill me, and now that person is still not up to speed. And it's like, the more succession planning you do, like the more planning you do, period, the more prepared you are for when changes happen, sudden changes.
Right. I mean, you mentioned succession planning, and I'll add separation of duties and job rotation. None of these exist in the OT role, especially. No, it's just one guy or one gal that knows how this thing works. And as long as they're around, you can keep it,
And it's not even written down anywhere. It's just in his head. So then when it goes down, you got to call him and be like,
literally someone retired and took the whole InfoSec program with them. Like, they didn't write it down. My tiny unicorn. No, one of the biggest things that gets me is like in all of my security, like academic documentation that we have, and like all the teachings that I just completed in my master's, it's like forced vacations, job rotation, like learn a new capability, shadow someone new, force them to take vacations. And then in reality, it's like, don't you dare take a vacation. You need 2 hours for surgery, you get 2 hours and have your phone on. It's like, we're not enforcing any of that. We're not doing these secure things. We are not doing any of these things that we, at the very basics, say everyone should be doing, because we are so short-staffed. We are so hyper concerned with like that one person not vacating their post at any cost.
Yeah, big challenge for sure. All right, do we have any questions from the audience?
I don't know if I see any in the Discords. Someone said amazing presentation. Thank you so much. We all agree that ICS is like a unicorn. Yeah.
Well, I guess that's in theme with the current GRIMMCon for sure. I think I should get one of those hats. Is it a hat or a tiara, or how do you get that?
It's like a headband. It's like a little.
Oh, headband. Yeah, there you go.
You steal it from your
Actually,
children.
it's a headband. I stole it.
I think that's one thing that, if you ever get to meet Bryson in person, given COVID and all, we should ask him to distribute more of these.
Yeah. I think
just
all
has
speakers should get a unicorn headband, like for uniform purposes.
Unicorn headbands instead of business cards. He just hands those out with his name and number on the corn.
That'd be great. A little QR code on the back.
Ooh, yeah, there you go.
There you go. Now we're cooking with fire.
Might as well throw GPS tracking in it too, and then just make it.
Might as well make that QR code go to a malicious landing page where we have a beacon listening back.
Malicious
I'm just kidding, children, don't do that. That's very bad and very illegal. Don't do it.
Well, you're then forcing people, right? If you get one bad experience, you learn from it. You're then forcing people to deploy all your links on a virtual machine that they can burn. You're telling them what to do.
So we do have one comment, and it's Jason asking you to stick around for the next talk, which I'm guessing Jason is the next talk, but
I'll be happy to. Yeah, I've been really enjoying the conference myself. I couldn't attend one, but because it's always a challenge, right? Which track you're on. But I've seen like 3 presentations so far, and really loved it.
awesome. So we got 10 minutes. Would you like to stay in our discussion about tacos?
Yes, we are about to have a very San Diego native discussion about tacos.
You've lived in Houston, so I know you've had at least Tex-Mex.
That's right. I've had my fair share of tacos and really good opinions about them too.
Ooh, okay. So
My favorite taco of all time is still the fish taco. I love a fish taco.
where? From where? Don't say Rubio's.
No, I mean their bowls are pretty good. They're like pretty good if you got to
We're on
stuff.
tacos here, not bowls.
I'm probably gonna go with like Wonderland Bar.
Where's that? I don't even.
OB, it's in OB.
Ocean
Right
Beach.
there at the end of, yeah, right there at the end of the boulevard where it curves around. Those are
I'll ask
those
you a
closer
simple
to-
question because that's what was on Twitter this morning. Someone posted and said there should never be an option to have 2 tacos. The whole thread was about you should get a chance to get 1 taco or 3 tacos, but no 2 taco business.
Yeah.
What do y'all
Why
think
are there
about that?
taco flights too? I don't want 3 of one kind of taco. I want one of like you have 12 tacos. I want to try multiple tacos. I want like a tiny sampler of each of your 12 tacos.
You go to so San Diego. If you go to San Diego, you have to go to Tacos El Gordo, right? So Tacos El Gordo, the closest, they were going to build one in Little Italy, but I think the closest one is closer to the border off of H Street in National City. And
I've never been there.
You've never been there?
I don't think so.
They have one in East County now. That's like a brother, but they have adobada tacos. Those are the best. Those are the best.
I don't know which ones you like. I mean, so being in Houston, right? Being in Texas, there are two distinct groups. So one is the actual Mexican tacos, and the other one is Tex-Mex. So they also joke about gringo tacos, where if you go to a place called Torchy's, it's in Austin and in Houston, they have special names for these tacos. These are, $5 tacos, not your typical, $1 tacos you get, but they have unique names. And either you love them or you don't, right? So people that love them because the ambiance, the atmosphere is wonderful, and you can pick like she was saying, you can pick a platter of completely different tacos, one of each kind, and that way you get to choose everything, from a weird combination to vegetarian to kind of beef, beef and fish mix. So the world is your oyster. I guess that talks about an oyster as well on a taco, but I've never tried. But
I've never had an oyster taco. I've had some weird tacos. Like I've gone straight cabeza and lengua and like you name it. So even venturing as far as lumpia, which is like a Filipino egg roll and tacos. That's
nice.
But I go TJ, like a Tijuana style taco is usually what I go for, which is just like little tortilla, a little bit of meat, usually 2 tortillas, and you go in on it. But living in San Diego, you just have a plethora of places to go.
Option.
Yeah. Especially that.
I always start with al pastor. When I'm not sure of a new place, I start with al pastor. If they can make that, because that's the simplest you can make, right? A little bit of pork and a pineapple. And if you can make that right, okay, that's a good place.
Yeah,
Similar to how I order a margarita pizza to test an Italian place, order an al pastor taco to test a taco place.
That is the key. Man, now I'm hungry. I haven't had lunch yet. We don't have a break. I'm over here drinking my second Red Bull, thinking about tacos. I'm gonna have to Uber Eats myself.
There you go.
Oh wait, I got an update. 1 second. So we got Jason going on in the next 5 minutes. Jason is going recording. Jason, are you in the Discord?
Oh, so Jason is here.
Oh, he's in here? No, he's not.
I'm asking.
I think Jason is here, but he's recording. There he is. Okay. Just making sure. I just saw an email come in and I wanted to verify.
Now, should I exit this presenter mode and then join as another?
I already stole presenter from you. You're fine. You can stay and hang out. You can
have the right script away.
You can leave. You can do whatever you want. You can stay with us the rest of the talks if you really want.
Gotcha. I'll probably end and join back as just a participant. That way it's cleaner, and then I can use my iPad for it. Thanks, folks, for chatting.
All right. Yeah, it's awesome having you. Thank you for showing up.
Bye now.